This video will be our introduction to graphing sine and cosine functions. Let's start off by taking a look back at the unit circle. Here we have a table of all the sine values for every point on the unit circle. I included all the radian measures, and I will be using radian measures exclusively for the rest of this video or any other video on graphing. When you're graphing sine or cosine functions, you only use radians. So if I were to plot all of these values using the angle measures in radians as my x value and the values of sine of that angle as my y value, let's see what that would look like on the graph. So this looks pretty interesting. My first point was 0, 0. You can see that here. And then the next point was pi over 6 for an x value and 1/2 for a y value. Then pi over 4 square root of 2 over 2. Pi over 3 square root of 3 over 2. And pi over 2, 1. And then notice that it started to work its way back down until I got to pi, which is 180 degrees, and the sine of pi is 0. Then it started working into the negative direction. Remember, in the third quadrant, all these points are in the third quadrant on the unit circle. Sine is negative. And in the fourth quadrant, sine is also negative. So it's the first quadrant was here, second quadrant was here, third quadrant is here, and fourth quadrant is here. And whether it's positive or negative, it all kind of fits in with what our values for the unit circle were. Connecting these points gives us an interesting looking graph. Certainly a lot different than all the linear functions we've graphed in the past. Has a nice curve to it, and it seems to reach these maximum points and kind of level out for a second before descending down almost linearly from here to here. I think that's just because the points are far enough apart from each other, and then it levels off again at that minimum value, goes back up to another maximum value past 2 pi. Remember, you can find the sine of any angle. It doesn't just have to be between 0 and 2 pi or 0 and 360 degrees, because after 360 degrees, all of the angles become coterminal angles with an angle that exists between 0 and 360 degrees. Even in the negative direction, we have coterminal angles that are negative and coterminal angles that are positive. So therefore, there's going to be a pattern that emerges in this graph. It's going to repeat itself. Every 2 pi, the entire graph repeats itself. That makes the graph of the sine of x a continuous pattern that repeats itself. So sine is not the only continuous periodic function. Cosine is as well. And remember, sine and cosine swapped values very often, quadrant to quadrant. Here in green, we have the sine of x. And in purple, we have the cosine of x. And cosine of x just seems to get everywhere that sine of x is going. It just gets there early. In fact, it gets there exactly 1 quadrant early. So if you just take the value from here and move it over pi over 2, which is 90 degrees, 1 quadrant, it would be exactly in the same spot as the sine value. Now, the graphs of sine and cosine are called sinusoids, which are a periodic graph because it has a repeating pattern. And this is actually really useful to model all kinds of periodic phenomenon. So, for example, anything that is a wave, like a sound wave or electricity or motions of a pendulum or the seasons of the year, you could graph any periodic nature using sine, cosine, and tangent. So if you're looking at an equation for sound waves, well, it's a sine graph or a cosine graph, depending on which one is the better one to use in that particular problem. Since we have a graph, let's talk domain and range. The domain are all the input values, possible input values. The domain for each of these graphs, both sine and cosine of x, are all real numbers. There's any angle that you can put in and find the sine of it. There's none that don't work. Now, tangent, on the other hand, has values that you can't find. They have undefined values. And if you remember the unit circle, some of the answers for tangent were undefined, and that would mean that the domain is not all real numbers. But for sine and cosine, the domain is all real numbers, meaning you can put any value possible in for x. The range, on the other hand, are all the possible y values, and that is bound. In our graph of sine of x, the range never goes above 1 or below -1, and it keeps bouncing back and forth between those two values. So the minimum is -1, the maximum is 1. There are ways to change the range, but we have to change our function going into it. But for the graphs of sine of x and cosine of x, the range is from -1 to +1. Amplitude is the distance away from the midline of our graph, or the middle of our graph. This is the middle line. Half of the points are above it, half the points are below it. And the amplitude is the distance from there to the highest point, or from here to the lowest point. You can calculate the amplitude as half the distance of the maximum and minimum, or 1/2 times the maximum minus the minimum number, which in this case is 1/2 of 1 minus -1. 1 minus -1 is 2. Half of 2 is 1. So the amplitude of this graph of sine of x is 1. The shortest repeating portion of the graph is called a cycle. So a cycle is where the graph starts, goes to its highest point, in the case of sine, back to the middle, down to its lowest point, and back to the starting point again. That is one cycle, and the length of a cycle is called the period. Since this is a graph of all the values we found on the unit circle for sine, the period is 2 pi. It's one trip around the unit circle. So far, you've only seen the graphs of sine of x or cosine of x, but there is ways that you can change the way that the graph of sine of x or cosine of x looks. You can make changes to the amplitude by multiplying a number in front of the sine or in front of the cosine, or you can make changes to the period or the length of one cycle by placing a number directly in front of the x. So you're taking the cosine of that number times x. Now, determining the period is a little bit more complicated because the period length is whatever the number in front of x is after being divided by 2 pi. And that will give you your new period length. Here you can see the effects of a change in the amplitude. So the purple graph is 2 times the sine of x, whereas the green graph is the one we've been looking at before of just the sine of x. And you can see that the amplitude has the same intercepts. It intercepts the x-axis at exactly the same points as the green one does, but its highest point is up to 2 now, not 1, and its lowest point is -2 instead of -1. It still carries the same basic shape, it's just much taller. Here you can see the effects of a period change on a graph. So the top one is the normal f of x equals sine of x. So what is the period of that? Well, for sine of x, there's no number directly in front of the x. So it's just 2 pi divided by 1. So the period of this would be 2 pi. And notice it starts at 0, goes up to its highest point, middle point, lowest point, and then once it finishes its cycle is at 2 pi. Now, beneath you can see the graph of sine of 2x. So 2 is actually going to be our new b, so 2 pi divided by 2, the 2's will cancel. This has a period length of just pi. So it's going to go to its highest point, back to the middle, to its lowest point, and then back to the middle again to complete one cycle in just in the distance from 0 to pi. So it starts, goes to its highest point, middle point, lowest point, then back to its original point again. That's one full cycle, and it did it in half the time. It just did it in the distance from 0 to pi. Now, as I'm describing these graphs, you notice that I keep stopping at very specific points. These are called the 5 key points you can use to sketch a graph. The key points are any intercepts of the graph, any place where it crosses over its center line, its midline, or in this case, over the x-axis. And also the highest values and the lowest values, those are also key points. And so with the graph of sine of x, the key points are 0, and then it reaches its highest point at pi over 2. Remember, that's like 90 degrees. And then it's back to 0 again at pi, and then it reaches its lowest point at 3 pi over 2, and then back to 0 again. So that's one cycle. And I want you to notice that each of these points are equally separated from each other. The distance from the middle to the highest point is the same as this distance from the highest point to the middle again, and then from the middle to the lowest point, and then from the lowest point to the middle again. Each of those takes the same amount of time. Now the graph of cosine, like sine, has 5 key points as well, but notice that the cycle of cosine starts at its highest point, and the whole goal is to get back up to the highest point. So it can go from the highest to the middle, then to the lowest point, back to the middle, and then the highest point. So the 5 key points on cosine includes 2 maximum values, 2 intercepts, and 1 minimum value. So let's try sketching our first trig function. I'm going to attempt to graph y equals 3 times the sine of x. Now, if I was just graphing y equals the sine of x, I know I start at 0, and then I go up to its highest point by pi over 2. So that would be here at 1, and then back to 0, and then its lowest point at 3 pi over 2, and then back to 0 at 2 pi. But there's something different about this. We have a change in our amplitude. Our amplitude is 3. That means my highest point isn't going to be 1. My highest point is going to be 3. So I'm going to draw that in. Our period, however, does not change. It's just 3 times the sine of x. The amplitude changes. The period, it's still going to start at 0 and end at 2 pi. So let me write that in, 2 pi for my period. Okay, so I'm going to start at 0, and then I'm going to reach my highest point. And since my amplitude is 3, that's going to be positive 3 in the y value at pi over 2. Then from there, I turn around and go right back to the middle of my graph, and then I will go down to negative 3, because the amplitude's the same on both sides of the midline, and then finally end up back at 2 pi. Now, when you're drawing your lines, don't make them straight lines and make them all boxed off. Have a little more grace with it. So this is how I like to do it. Now, I am not a talented enough artist to do this in one stroke like I should be able to, but I know it levels off when it gets to the highest and the lowest values. So I kind of start from the high points and the low points. So I'll start at pi over 2, and I'll just level it off and then go kind of quickly down to the midpoint. Same thing on the other side. Start off a little level, then go quickly down, then quickly down, level it off a little bit as it gets to that minimum value, and then come back around the other side. It should have some sort of arc to it. It shouldn't just be straight lines. All right, now let's see what the computer can do. Yeah, that's a little better, but mine still gets the point across. Let's try another one. All right, sketch the graph of y equals 2 times the cosine of 2x. So we have a change to the amplitude, and that would be 2. And we also have a period change here, which is another 2. But remember, when we're determining our period, it's 2 pi divided by whatever number is in front of that x. So in this case, it's 2 pi divided by 2. The 2's will reduce, and we're left with just pi. So now we're going to graph the cosine with an amplitude of 2 and a period of pi. So I know I have to get this entire thing to start and end, start at 0 and end by pi. But we are talking about cosine. Cosine starts with its highest value. So my first point will be up here at 2. And my last point will be up here at 2 again. Halfway in between that, I will be at my lowest point, negative 2. Halfway in between each of those, here and here, I will be in the middle. So we could just do this. Perfect. Now, if we wanted to, we could keep going with this. We just do the same thing. 2 pi, it will be back at its highest point again. 3 pi over 2. This should look identical to your first cycle. And we could just keep going even further. We could go back in the negative direction if we wanted to. Let's see. We'll be at its lowest point there. So, and then middle point right there. Hey, not bad. I will take that. Okay, I think it's time for you to try graphing some of these on your own.